Okay. So this talk is going to be in English. However, at any moment as we go through, please feel free to raise your hand, and if there are any questions, we'll go through in the moment, or we can wait till afterwards. Questions can be in English or Spanish, I don't mind. So it's going to be around 30 minutes, depending on how fast I talk, how nervous I get, and how many questions you guys ask me. And okay, so let's get started. So here's what we're going to talk about today: the team's workflow, why we needed Swarm, so that you guys understand the use case, why we needed it, and why we implemented it. Then we're going to showcase it. We'll go into a little of the technical details of the Swarm that we created. And then we'll talk a little about automating it, about actually making this automatic so that the deploys were automatic. And then of course the obstacles, because it wasn't easy. It's much easier now with Docker 1.13. But before that, I'll show you the obstacles and the things that we had to get over with 1.12 and how it's going to be in 1.13. So my aim with this talk is to show you how to automate it, if you want to automate things like this, how would you go about it, so that if you do decide to do something like this, you'll know the pitfalls. So about me, I'm a DevOps engineer. I work in Sun Transfers. I work remotely. It's actually a company in Barcelona. I work remotely from here. I've been working there for maybe nearly 2 years now. And around that time, I've been a DevOps. So I'm a DevOps for about 2 years. Before that, I was PHP, and I used to love clean code and structuring things very well, and all the good code styles and things like that. I really like that. So I'm a bit of a perfectionist. And I'm a big Docker fan, partly because I love the automating all the things, and you know, the testing it automatically, writing good tests. The idea of clicking one button and boom, all the tests go green, and all of a sudden it's in production automatically. I love all that. And so I love Docker because it enables all that. It makes it very, very easy to do those kind of things. So a little bit of interesting thing. My personal, I'm sure you guys all have, you know, your own little server that you host your projects on and things like that. Well, mine is a Docker Swarm. I have maybe 10 or 15 projects there, and they're all Dockerized. Everything I do is Dockerized. And I'm author of a Docker course on Udemy, and there's another course in progress. So because we're going to be talking about Sun Transfers, I want to give you a little bit of an update so that you know about them. So they have a website, and the service they offer is to pre-book taxis between airports and hotels. So if you've booked your hotel, you've booked your flight and you've booked your hotel, and you want peace of mind, you just go onto this website and boom, you can book a taxi for whenever you want. The company's around 9 years old. And to give you an idea of the team, the technical team is around 10 people. The 2 of us are sysadmins. I count myself in there. And the rest are PHP, JavaScript, and designers. And as I said, the office is in Barcelona. And in total, the office has about 50 people. I could be way wrong there. Yeah? I haven't been in the office for a long time. So let's talk about the team's workflow. It's completely PR-based, so we use GitHub. We use GitHub for everything. We have around 40 different repositories in GitHub. Only maybe 6 or 7 of them are actual projects or actual websites, actual appies, and the rest are like libraries, PHP libraries, JavaScript libraries. There's a few repositories for different Docker images, stuff like that. But all of the projects follow this flow. So whoever's making a change, they make the pull request, and they want to merge it in. On that pull request, I'll pull this up so that you can see it better. On this pull request, okay, so you can see there. This is a real issue that I pulled like yesterday. So we got 3 people who have reviewed this, and then we got lots of little checks. These checks are all in the GitHub thing, and they're all driven by Jenkins. So Jenkins runs all of these checks. So you can see there that we run the bhat critical tests, We run the deploy pre, we'll see that later. The Docker build is also run by Nimble CI, we'll talk about that later. We run a few translations tests, JavaScript UTs, PHP unit tests. So the idea is that we know before we merge if it's working or not. Okay, so now let's talk a little more about the swarm itself. Okay, sorry. So because of this, we wanted this swarm because for every one of those pull requests, we want to test it beforehand. Not only automatically, we want to, for example, if there's a design change, we want somewhere where each task is deployed, and we can, click through the things, see the difference in design, make sure that the functionality is the same. Because there's another check in GitHub that we enable, which is that the branch that you're going to merge must be up to date with all the changes in master, which means that if the merge does go ahead, what's in the branch now is going to be exactly the same as what's the branch in master. It's going to be a clean merge. So that means that we can deploy this branch knowing that this will be exactly what's in master after we merge. So we wanted a place where we could test this. So enter pre. This is our swarm. Pre is our swarm. So this place we're going to deploy all of the pull requests, and we're going to run automatic tests. The bhats, for example, they're run automatically against this environment, and we can do manual testing there if we need to or whatever. It's just there for testing. So imagine right now it's only one server. It's only one physical server. Well, it's a virtual server, but it's only one. So it's a swarm of one. It's got Docker 13 on it, 113, and it's got a wildcard DNS. So everything at before pre.suntransfers.biz points to this server. So everything's going there. So this means that we're going to be able to put, and at the front of this URL, we're going to be able to put the task-specific bits, and they're all going to be routed to each task. And then for that routing, we use Nginx proxy running as a service, and that does the routing. For those of you who are not familiar with this, here's very, very quickly how it works. So this is just a Docker Compose file with two services. The first one is the Nginx proxy. You can see we're mapping port 80. So the entire port 80 on the swarm is now completely occupied. It's taken over by the reverse proxy. So the reverse proxy is listening only on that port. And that's what makes, so all connections are going to come through that because they're all pointing via DNS. They're all going to point to there. And it listens to the Docker socket. It's a read-only, so it's constantly listening to all of the events that are happening on the Docker host. If the containers come up, if the containers die, all of this. It listens to everything. So here's another example service, and we've got, it's just and whatever, it doesn't really matter, but the important thing here is the virtual host environmental variable. So our Nginx proxy is listening for this variable. So if it hears a container coming up with this virtual host variable, it automatically and dynamically in the background creates the virtual host configuration to do that routing. So it's like automatic for us now. We don't have to worry about it, which is very cool. There is one drawback to this, which is that this doesn't work for multi-host swarms. So this is an improvement and that we have to make, but the concept is the same. So here's, I don't know if you're going to be able to see that, but here is a screenshot of all the services that we're running, well, some of the services that we're running on our swarm earlier on today. So you can see there are a lot of different services. So for example, here, let's look at this one as an example, this booking web 1960. So this is one task, this is one pull request, and it's in the booking project. And you can see here that there are 4 different services involved with this. So for every pull request, there are 4 different things that need to be deployed for this to work. And so we've got an API locations, we've got the booking service, we've got Redis, and we've got the web service. So these 4 services have to be deployed for any pull request in booking, for example, because they're needed for it to work properly. And as you can see, there are lots of other tasks in here as well. So I want to draw your attention to these 2, the log spout and the proxy. The log spout is just listening to standard out from all of the containers, and it's routing them to papertrail. We'll see that later. And then the proxy is the same proxy that we saw before. That's listening to port 80 on the server, and it's depending on the virtual host of each container, it's directing the traffic to the correct container here. Any questions so far? How are we doing? So now let's talk about the automation bit, because in theory, starting a service on a swarm is easy. Use one command, we're told. So let's look at some real code, because well, up to 113, it wasn't one command. So we use Ansible, by the way. If you don't know the internals of Ansible, or you don't know how it works, don't worry. I'm going to go very, very quickly over the concept. So the concept is the same. Basically, we need to run a command on the remote server to start this service, is basically it. And we do everything with Ansible, so I'm going to show you that. So this is the playbook that we use to deploy a customer. I will definitely need to zoom in. Well, how's that? So the important thing here really is the role. We're going to run the deploy Docker service role, and we got some variables here. We want to deploy the customer project and the tag. So the tag is, remember that at this stage we're deploying something. We're deploying a container. So at this stage, it's already built. So Jenkins has already done the build. It has built the container for that individual pull request, and now we're going to deploy it to the swarm. So this tag is like the branch name or the task name. It's whatever identifies the task. So now let's look into the deploy Docker service role. So here are the roles, deploy Docker service, where is it? So the entry point is always tasks main for the role. And so here it is. There are three things that happens. These all happen on the swarm itself. These are all just run on the swarm. So first thing, we ensure that the deploy script directory exists, which is just opt deploy scripts. Basically, we just make sure that that directory exists, nothing fancy. Then we're going to make sure that the deploy script is up to date. So this deploy script, this is la chapuza, I call it, because until Docker, the big problem was that in Docker 12, there was no way to idempotently meaning there was no way to run one command to make sure that the service was started. And that was a big problem. So we need this fantastic script. So we are going to template this script onto the remote swarm, and we're gonna fill all the variables in, but basically we're just copying over a script, and I'll show you the script later. And then we're going to run the script, and then boom. So let's have a look at the, I closed it. Let's have a look at the template. We're interested in the customer one. So here we go. First of all, so remember this is run on the swarm itself. First of all, we're just going to log into the private registry. And then next, we see that there are these kind of if-else blocks, and there's lots of these. This is the first one's for the Redis, the second one is for the customer. Next is for the API booking, etc. So the concept is the same, so we're just going to go through one. First, we pull this image, and we pull the tag. The tag is the branch that we've built, so we pull it down. And then we get the commit hash from this tag by running, it's not very clear there, by just doing a cat of rev.txt. And we do this because, so every image that we build, we actually put this file in there ourselves because we want to, okay, so this all comes because there was a bug in, I can't remember which exact version, I think it was 1.112 something. I think it was also fixed in 112 something as well, 112.3 or something. But basically the bug was that if you tried to deploy twice or update the same tag, the Docker engine said, oh yeah, I'm already up to date, I don't have to do anything, and it didn't look and pull down the new one. So because of this, we specified the exact commit hash, the exact image, so that if it didn't have it, it would definitely pull it down again. So now, once we've got that, next we have to check, is the service already running? Because of course, if it's already running, we cannot run Docker service create, because Docker's going to say, no, can't do that, can't create it, it already exists. And likewise, if it doesn't exist and we try and update it, no, that's not going to work either. So this ugly if. So we check, are there any services with this name? And if there are, well, then we update it. And if there are not, well, then we create it. So this is very, very ugly. But this is with Docker 113, it's back to one command again, and everybody's happy. But this was interesting that we had to go through all this exercise because it was the only way. So that was, we saw first the Ansible playbook, then we saw the role, and we saw the Hacky Chapuza script. So next, I'm going to talk a little bit about the monitoring, how we monitor this thing. So for the system metrics, we just use Datadog. We have a paid account on Datadog. I'm just going to show you very quickly the dashboard. So this is standard stuff, eh? This is, we have alerts in here to let us know if anything's going crazy. We have memory, we have load averages, available memory, available swap, all that kind of stuff. And we just have alerts in there. So that's. And then the container logs, as I mentioned before, we have a logspout image, logspout service, which just forwards all the logs from all the containers to Papertrail. And we should be able to see those. And there they are. So there's lots of logs, and they're just all forwarded in there. So the obstacles that we came up against. Well, the first one was the create update commands were not idempotent, which made us need the script. Then, of course, the bug, which meant that a tag wasn't updated without specifying the exact hash. That was a real pain. And then the Nginx proxy does not support multi-host swarm mode. That's not a problem for us now because we only have one. But there are alternatives like this traffic, which is exactly the same. It's the same concept, but yes, it does support multi-host swarms. And then I had many headaches with the storage drivers. I was experimenting with many things, and the disk would fill up. We wouldn't be able to recover space. I'm not an expert in this, so I can't tell you exactly what the problem was, but now I know that we're using overlay 2 on Ubuntu, and it's working. So let's go back to Jenkins for a moment, because all of these jobs, I said that Jenkins was coordinating all these. So let's jump into a bit more detail on these. So for every change in the pull request, for example, if a pull request is opened, if somebody comments on the pull request, if the pull request is closed, GitHub sends a webhook to our Jenkins. We have a private Jenkins. And then Jenkins parses the webhook, because that webhook contains a lot of JSON. It's a big JSON with lots and lots of information in there. And our Jenkins parses that. So I'm going to show you the script that does that parsing. And we'll see the decisions that it makes. So this script receives the GitHub webhook payload and triggers the next jobs. You just pass it the Jenkins URL and the payload. So this is not really very important. The important thing here is that we get the action out of the payload, we get the comment out of the payload, and we get the project name out of the payload. If the comment is not null, but it was deleted, it means that a comment was deleted. We don't care. But if the comment was not null, then somebody commented on the pull request. And now we're going to see, well, what did somebody comment? So this allows anybody to comment in the pull request, and then our Jenkins will read the comment and then trigger whatever needs to be done depending on the comment. So for example, if somebody types repeat Jenkins, it will trigger everything. If somebody types repeat Jenkins unit tests, it will only trigger the PHP unit tests. So this is it's just parsing the payload and triggering. And then if there was no comment, but the pull request had a code change, well, then we're going to, if the pull request is opened, we want to trigger everything. If the pull request is closed and it was merged, we want to promote this image. So we'll come back to this, but basically the build builds the image, so it builds for that pull request. But because we said that the branch is always up to date with master, we know that when we merge it, it will be master. Because it's a clean merge. We don't need to worry. It will be a clean merge in. So that means that when we merge, we don't have to rebuild the Docker container. We just promote it. We just say, hey, you are now master, and that's just retagging, and that's very, very quick. So that's what we do here. We promote that image. We promote it to master. And then we publish an NPM version if we need to. And then finally, we kill the pre-containers, because we can't just be putting lots and lots of pre-containers, lots and lots of containers on this swarm. We need to clean sometimes. So when the pull request is closed, we kill it. We just close the close the servers. So that was the code that Jenkins used to So now I'm going to show you the Jenkins jobs just so that you get an idea. So here they are. There's not too many of them. And these are the same for each jobs. If you want, we can just ask me a question later on and we can go into more detail about how these work. But basically, you can see the GitHub endpoint. This is the GitHub endpoint. There's the Docker promote. There's the Docker build. There's the deploy pre. And most of these, for example, the deploy pre just runs the Ansible playbooks to actually do the hard lifting. So I mentioned about the building, and we had two things building. We had Jenkins building it, and we also had Nimble CI. Nimble CI is something that I built for exactly this. It does exactly the same as the Jenkins build job. So what this does is it builds each pull request. It receives the GitHub webhook. It builds each pull request. It pushes that tag to your own repo. And then it has webhooks to trigger whatever else you need. If you want to deploy it somewhere, if you want to run tests in that container, you can do whatever you want. And then optionally, your tag can be promoted when the pull request closed. So it's the same thing that we've developed here, but in a nice, easy-to-use package. So I recommend if you guys are interested in making a workflow like this, check it out because it will make your life easier. So we're wrapping up. So we talked about pre. We talked about what it is, why we needed it. The bits involved in it, it's not complicated, and it's getting easier with Docker 13. We talked about some of the problems with automating the workflows, and most of them are solved by 1.13, but we have to update our scripts. And we talked about our team's workflow and the steps in continuous integration and what Jenkins does, etc. So that's me. If you have any questions, I'll answer them now. I just want to mention that I have 2 blogs there. The first one is about Docker stuff, and the second one is more personal stuff. You're more than welcome to follow me there or on Twitter. And these slides are available. I'll post a comment in the Meetup group so that you guys can have these slides. There are quite a few links in there that you can use. So if anybody has any questions, I'll be happy to answer.
Hi, thanks for the talk. Just wanted to ask a couple of questions. First, are you using any volume driver to store the state, or just do bind mountings for the databases on the host?
So we don't use the databases in Docker. I actually wrote a blog post about this, and I don't recommend that you put your databases in Docker, because unless it's a testing thing, unless it's something that, like for example, I suppose we could do it here, but if you're really doing this seriously and you want to put this in production, putting a database in Docker is not a good idea, because that whole ecosystem of volume drivers is not mature yet, and there are already experts who can fine-tune a database on its own server very, very well. But so no, we don't do it, but it can be done, of course, yes.
Okay, thanks. And the other one, have you tried the Docker application bundles for orchestrating several services at the same time?
Exactly, yes. So we are going to use that instead of our Chapusa script. We're going to remove that, and we're going to use those bundles because it's much easier.
Thanks.
Okay, well, that's me. Thank you for your time.